Hey guys, here are some practice problems for you to look at for the test. They're included in this same post. It's like equilibrium practice problems or something. There were two big types of problems in this chapter. There was the ice chart, and there was comparing Q and K. So I'm going to do one of each. I feel like with the Le Chatelier's principle stuff too, that you're looking at one or the other of these on this quiz. So we've got this one, and I'm not putting up a lot of the information because I put it already in this post, but what we start with is that bromine plus chlorine makes, I don't like that compound, BrCl. It looks like a fake halogen. But there's two of it, Kc of 7.2, and we're given initial concentrations for both Br and Cl of 0.200 with nothing of 2BrCl. The problem a lot of you had in the initial problem was that you didn't know which way the reaction was going. In the one in the packet, the example, we really had to look, and we had to figure it out. You can do this given Q and K, and in longer problems you might have to, but in this case, since we're looking at an equilibrium and there's no BrCl, we're going to make some. That's a safe assumption if there's nothing of something, because you can't use it up. There's no way to make more Br and Cl if we don't have anything to make it with. So in this case, my change here will be minus x and minus x. I'm using those up to make some of this. I'm not just making x of it, I'm making 2x of it because of the 2 out in front. So I'm going to have 0.200 minus x, 0.200 minus x, and 2x for my concentrations. But they got to go somewhere. If I write Kc, BrCl on the top, and it's squared because of its coefficient, Br2, Cl2, there on the bottom, and that's the equation I'm going to use with these. So I'm going to do 7.20 equals 2x on the top, but when I put it in, it's 2x squared, because it's squared there. Here, I'm going to end up having 0.200 minus x twice. So I may as well say that that times that is that squared also, which sets us up just like your practice problem for that, for the giant square root thing. So what I end up with, when I do this, and you're welcome to work through too, I end up with the square root of 7.20, x over 200x, by the time I have solved. So, 2x over 200x. So, square root of 7.2 equals 2x over 0.200 minus x. Following from here, it looks like, well, let's see. My square root of 7.2 is going to be 2.68. So this is going to be 2.68 times 0.200 minus x equals 2x. So 2.68 times 0.2, 0.536 minus 2.68x equals 2x. 0.536 equals 4.68x. So divided by 0.536 divided by 4.68 looks like x equals 0.115. So my concentration of BrCl is going to be twice that, or 0.2, it comes up as 0.230 molar. So there's my concentration of Br and Cl, and 0.2 minus 0.115 gives me a lower concentration of Br and Cl for 0.085 for both Br and Cl. Double check me on the math. I just ran through that now, but that should set you up once you get to here to work through to solve for X and get that one. Now for the Q and K one. This one's a little more straightforward. There's no ice chart. So just give me a second to get it cleaned up. We're looking at KPs here, and one of the comments was how you write KP on your papers. We got PCl5. We can avoid writing out the gas thing here because by saying KP, we know they're gases. So my expression for KP is going to be my partial pressure of PCl3 times my partial pressure of Cl2. This is pretty nice. There are no coefficients, so nothing squared or cubed. P, Cl5. There's my KP expression. Now, I gave partial pressures and a KP value. So those partial pressures, it says, aren't at equilibrium. So if I want to calculate Q, my pressure of PCl3 is 0.150. My pressure of Cl2 is 0.250. And my pressure of PCl5 is 0.00. 0.00? Just 0.0500. So I'm going to solve that for Q. 0.15 times 0.25 divided by 0.05 gave me 0.75. What Q is the same setup as the equilibrium constant, but not at equilibrium. So this reaction is going to have to shift to get to equilibrium. We're going to compare Q and K. We're going to compare 0.75 to the K value, which is there. Our KP was 2.15. It looks like Q is less than K. 0.75 less than 2.15? Awesome. So when I do that, I know that if Q is less than K, it means I'm dividing by a bigger number. It means then I have more reactants than I should. And the reaction is going to shift to make more products. That seems crazy because there's so much less of the reactants in the products. But that's the way the reaction works. When I solve, Q is less than K. So to fix Q being less than K, I need to make more at the top, less at the bottom. Make my number bigger. So the equilibrium will shift to favor making more of the PCl3 and Cl2. I'm also asking you here to calculate Kc given Kp. It's pretty easy on this one. So my equation to do that, Kp equals Kc RT delta N. Delta N for this one. There are 2 moles on the right and 1 on the left. So my change, my delta N, is 1. Good. So I need to solve for Kc. It looks like then, if I wanted Kc by itself, I'd get Kp over RT for Kc. So 2.15 over 0.08206. And my temperature was 250 degrees Celsius, or 523 Kelvin. When I solve for this, just enter in the calculator. 2.15 divided by 0.08206 and 523 gives me 0.0501 for my Kc from Kp. Be able to do that both directions. Hopefully these help set you up for the test. Again, office hours Monday. See you then if you need to. We'll be reviewing.